through. Yeah. Okay, we'll continue now. So what, if you want to open up the next, we did last time the first principles, wasn't it?
Yeah.
And then I think the next one is differentiation by rules.
Question.
Yeah.
Are we going to continue calculus in second semester?
Yes.
So
What will happen is we'll finish the calculus and then we'll do a little bit of probability, which will continue into semester 2, and then we'll return back to the calculus. So we'll break the calculus up with probability in between. Okay. Right, let's just have a look here. Nathan? Okay. So the next topic is actually what people would be more familiar with when they've done calculus in high school. It's differentiation, but not by first principles, by using differentiation rules. So what I'm going to do, let's just zoom in a bit here. Oh yeah, hang on. Duplicate there. So what I'm going to do is, I'm going to prove one of the rules, but I'm not going to do the proof for all of the rules. I'm going to prove the rule for x power n, because this is the one that they like to ask you by first principles in the exam. So you remember last time I told you, sometimes they ask you for the proof, the derivative by first principles. And I think I was saying to somebody that, somebody was asking me what type of function, and I said it's usually, do you remember? Oh yeah, sorry. It's usually what type of function in the exam? It's a quadratic, I said. So they usually give you a quadratic, and I said in the worst case, a cubic. And they ask you for the derivative by using first principles. So what we're going to do now is we're going to figure out, and I know many people know this rule already, if you have x power n, what's the derivative? Yeah. So we'll have a look at the proof, and then after the proof I'll just give you the list of rules that you would have. Okay, so let's have a look here. We can see that. Right, so we have y equals xn. So the derivative. Now you should write this down because this is good practice for your first principles. Derivative equals x plus h power n minus x power n over x plus h minus x. Okay. Now actually we're missing a few people, aren't we? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10,
Yeah.
11, 12, 13, 14, 15,
A lot of people. Turkey, Juliana, Adnan, Vangela.
Turkey, Juliana, Adnan,
Vangela.
yes, someone's at GNIB today.
Moza.
Moses at GNIB,
Nubla.
and Nubla, and then Panjula,
Yeah.
also GNIB. Okay. Right. So what can I do here for this part to simplify it? What can I do? Yeah, what? Expand. How? Using what method? Pascal? Nah, not Pascal. I know you didn't say this. No, good. What method? No, well I can, of course, okay, the bottom, I can at least do this. Yeah, okay, but what about this part
What
still?
difference does that make?
Not much, but I'm looking at this part. Guys, come on, what can I do? How can I expand this? I can.
H to n.
Oh guys, come on.
X to n.
I can use this to expand it. Yeah, so...
Oh.
Oh, did you? Did you really? Right, so what's the first one here? It'll be NC0, and then you have X and H, plus, and the next one? NC1, x and h plus nc2 x and h, etc., minus xn all over h. Yeah? Yeah, you got this? Now, I haven't put the powers on, so I'll start with the bigger power for x. So this would be n, and what would this one be? No? 0. And this one here? N minus 1, and this one? 1. And here? N minus 2, and this one? 2. Okay. So on the top, we'll get NC0 is 1. Remember, the first one is always 1. And that would be xn. And actually, someone might remember what NC1 is. It's n. Now come in. Are you going through? No, okay. Then I don't know why. So what are you doing there? They're distracting me. They're distracting me.
والله عندها والله الناس هنا كلها عندها عقد والله خلي الناس دي تيجي مصر يتعلموا ازاي يعيشوا والله عندها ولا.
Okay. Does anyone remember what MC1 is? MC1? N, yeah. Now, you have the next one. What? Go on, come on, get out of my face, come on. Trouble. Okay, and then here we have xn minus 1 and h. Now, do you remember a while ago we actually did NC2? It was required in one of the questions. It became a quadratic. Yeah. NC2, I'll do it on the side here to remind you. It's n minus 1, n minus 2, etc. Remember, the top is n factorial, 2 factorial, n minus 2 factorial. So that's on the top, and then we have 2 times 1. And then here we have n minus 2 times n minus 3, n minus 4, etc. So all of these cancel, and you're just left with n times n minus 1 over 2. This is something we did in the binomial worksheet. So if you want to write that down, NC2 is actually n times n minus 1 over 2. And we'll go back and use that result. This method, first principles, yeah, for the exam. Okay, can I go back? So, I really just need you to write this part down. This is the key part here. I'm going back. Right, so here we have plus n minus 1 over 2, xn minus 2, h squared, etc., minus xn, all over h. Now, two things cancel on the top. Can we see what those are? Yeah, this one will cancel with this one. Okay. Now, what's in common on the top? Here we have a h, here we have a h squared, and the next one will be h cubed, etc. So, because there's a h in everything now, this cancels this, and what will this one become? H squared, h, and the next one will become h squared and so on. So now we are left with n xn minus 1 plus n minus 1 over 2 xn minus 2h plus more terms. But they all have h in it, which is all I care about. Because when I make h goes to 0, these will all go, leaving me with just this. So, if y equals xn, then that means the derivative will equal n xn minus 1. So this is actually our first rule.
Oh, I'm sorry.
Well, that's
Yeah.
this rule.
I got confused. Why did you cancel the n?
Which one?
After the sx and minus.
D is.
Yeah.
There's a h in
No,
the,
I mean, it's
here. H goes to 0 at the end, and everything has a h in it.
Yeah.
Okay, can you write this down? So this is your first rule of differentiation, derivative of x power n. A rule which you all have seen before when you've done calculus. No. But write it down. It's good practice for your first principles, which has been on the exam before.
Is this this proof in the exam? We have to give a proof?
Yeah, but only when n has a certain number value, like x squared or x cubed.
Oh. If it was x cubed, we just put in the numbers in the end of the answer. I mean,
One way you could prove it is you could prove this and then at the end say let n equal 3.
yeah.
I mean that's another way to do it too. Or you can just put 3 in from the start.
Oh. Yeah.
Yeah. It does whichever, it doesn't matter. Okay, do we have this?
Yeah.
Yeah. Now, before I give you more rules, let's just do some examples with these. So, we'll take some examples here. Find dy dx for each. So we'll put in 5 examples. So we'll go with a simple x cubed, and then we'll say 2x squared, and then we'll have a 4, then we'll have a 1 over x, and then we'll have a 1 over root x. So we'll do these ones together. If you want to write them down, please. Let me just move this up a little bit to make some space. Find dy dx for each. And of course this is y equals. Okay. We'll do these now once you have them, yeah? Got these? Yeah, okay, so let's have a look. So the first one, in words, what the rule, where's it gone? The rule basically says, bring down the power and then reduce the power by 1. So, if you have a power, it just means bring it down and take 1 away from it. So, this one here would be 3x squared. The power comes down and you take 1 from the power. So that's an easy one to get started with. So write that answer down. Let's have a look at the next one. So we have here dy dx. Yeah, it'll be 4x power 1. Because the 2 comes down. 2 times 2 is 4. And then you take 1. So in other words, the answer is 4x. Now what about this next one? It's interesting because there's no x in it. So you could think about this as instead of 4, as 4x power 0, because x power 0 is 1. So here we have dy dx would equal 4 times 0, which is 0, x power minus 1. So in other words, it's 0. So constants become 0 basically. Yeah. Now, what about this one? Well, before I started, I should change this into x power minus 1. And now I can use the rule. Dy dx equals minus 1 x power minus 2.
Yeah.
So this is minus 1 over x squared. Yep.
Do you have to put in that form again?
No, it's okay. Sometimes in the exam they ask for this, sometimes not.
Okay.
What is this one as a power? X power
Minus
minus a half. Yeah. So then we get dy dx equals minus a half x power minus 3 over 2. Yeah, and this, if you were to write it back, would be minus 1 over 2 square root x cubed. Yeah, because power half the square root, guys look carefully, the minus here makes it 1 over. The half here makes it square root. And the 3 here makes the cube.
Yeah, we did this.
We did this.
Yeah.
All of this.
Okay, write these 5 down, please.
In the first one, how does it become 3x squared?
You bring the power down,
Yeah.
and then you take 1 away from the power.
It's the rule.
We'll give the zero
It's
there.
the rule here. This rule.
This will be a different A, right?
No, A or B.
Yeah.
Give the zero.
Oh, something like this would just be
Zero?
a small part of an A. Question here? It's the same thing. You could do square root x cubed or square root x all cubed. Yeah. Yeah. Okay, write this one down, please. Okay. Can I continue? Yeah. So, like I said, basically we're just using rules here, and I'm just going to give you the list of the rules. All the rules can be proven using first principles. So here are the results. The first one, we have it already. If y equals xn, then dy dx, we just said, equals nxn minus 1. The next one is if y equals sine x. Does anyone know this one? Cos x. If y equals cos x, then this one is minus sine x.
What?
These are the rules for derivatives.
Yeah, but why is sine x equal cosine x, and when it's cosine x, it's
We can
equal to
prove this
negative?
one. We can prove this one using first principles. No, we won't do it. Relax. Relax.
Yeah, you just calm down. We can ask some questions.
I won't do the proof, but just to show you what I would have done. But I can't really do the proof because of the time limit. I'm just calculating this. So what you would do is, it would be, for example, sine x plus h minus sine x all over x plus h minus x. If you continue with this, it ends up simplifying to cos x. Now the proof is actually too difficult for semester 1. We can't actually prove it till semester 2. So what I'm doing is I'm just giving you the results. That's all you need for this semester. These are in the formula book as well for the exam. So you'll get a list of these rules in the formula book. So sine x is cos x. Cos x will become minus sine x when we differentiate. The other one is e power kx. This becomes k e kx. So if the k was 1, ex would become ex, which is an interesting one and an important one. In which one? Yeah, no, I'm saying if y equals, oh yeah, sorry, thank you, k up here. If y equals ex, then the derivative would be just ex. It's the same thing as this. The other one, we have sine, cos, oh yeah, tan. Could you wake him up, please? Thank you. Now that's the second time you've fallen asleep in my class. Third time, I won't wake you up. I'll just kick you out. And you'll be outside on the ground and you'll be going, how did I get here? Really? Yeah. I might be just straight out the window, okay? Yes? Right. Tan x. Does anyone know tan x? Good try, but no, not cotan. Yeah, 1 over cos squared x. Yeah. And then the last one is log x. Does anyone know the derivative of log x? Yeah, 1 over x.
Any more rules?
I think this is all you need for semester 1 exam. Is these
Semester
ones.
1.
And I don't think we have to memorize it. It's going to give us the equation.
These are in the formula book.
Yeah.
So you don't have to memorize it.
Yeah, but you should be so
Yeah,
familiar with them that you
look
don't need to look up the formula books. Can I scroll down now? Do you have these rules?
Yes.
Yeah. So let's look at some more difficult ones, just a little bit more difficult. Okay. Guys, look. Try this one. Try this one.
5.
I'll give you 1 minute to try this.
One minute.
Yeah, you're using the last rule in the table. Okay, what answer did we get? 2 over x here. Now, this will catch some people out because some people will go automatically to using this rule. But this is the rule for log x. This is not the rule for log 5x squared. So what you need to do is simplify this a little bit before you start. So what is the first rule of logs? Log AB equals log A plus log B. So this is log 5 plus log x squared, because here I'm multiplying.
And then log 5.
And then this is log 5 plus
2 log
2 log x. Now we have log x. So what is the derivative of log x? This is 1 over x. So this is 2 times 1 over x. Now what's the derivative of log 5?
0.
Yeah, why 0? There's no x.
Yeah.
It's a constant. So the answer is 2 over x. Okay, I'll give you another one that's a little bit tricky to try.
Trickier than this.
A little bit. A little bit. Okay, can I scroll down?
Yep.
Yeah. Right, so if y equals okay, I won't make it too tricky. X squared minus 1 over x minus 1, then find dy dx. So again, before you can use the rules, you need to simplify this.
Okay.
You have it? Right. You have the answer over there, I see, yes? Yes. Did you get an answer? What did we get?
1.
1, yeah. So, how can I simplify this? There's two ways to simplify it. What did people do?
Factorize it.
You factorized it, yeah. So on the top, it's x minus 1 and x plus 1, and on the bottom, it's x minus 1. So you're left with x plus 1. If you didn't like that, you could long divide, and when you long divide, you're also left with x plus 1. So either way, it's x plus 1. So here we got y equals x plus 1. And the derivative, well, if it helps, this is like 1x1. So it'll become 1x0 plus 0, which is
1.
1. Why is what? Here, there's no x. So it's just 0 then.
Oh, so
Yeah.
you have to break it apart.
Yeah, you have to simplify this first. Yeah. Okay, let's have a look at another one then. Can I scroll down? Yes? Okay. Try this one. Y equals sine squared x plus sine x plus cos x plus cos squared x.
Oh.
It's really not as bad as it looks. Find dy dx.
No idea.
It's easy, right? I think
It's not too bad. It's like the other two examples. They're actually quite short once you simplify it. We have answers?
No, not yet.
Not yet? What did you get? No, don't be shy. What did you get? Are you giving me the final answer? Not this. Cos x minus sin x. Because what you can do here is you can change this into y equals sine squared x plus cos squared x, of course, plus sin x plus cos x. Now you might remember what's sine squared plus cos squared? 1. And what's the derivative of 1? 0. Sin x, cos x minus sin x. So this is the answer here. Okay, what I'll do is I have 3 more examples to do, and then you can try some from the worksheet.
you just need for
How about 5 minutes break?
No, come on. There's only 10 minutes left in the class. Man up, please. Okay. Oh, come on, I'm in. I'm giving you 1 sip of coffee, then I'm continuing.
2 seconds. That's all. You said coffee.
Okay, I need 2 sips, that's all. Okay, next one. Right, try this one now. Y equals 1 over e2x. Give me the derivative. Right, do you have this?
No. minus 2 e times 2.
Guys, you have this one? You have this? No? Sharon, you have this one now? Yeah? What did you get? No? Okay, let's have a look. So, what you do first is you change this into e minus 2x, and then using the rule, this will be minus 2 e minus 2x, or just minus 2 over e2x. Okay.
You're right, it's a little less, right?
Both are fine. Now, Nathan, Sharon, please. Now, we have some notation I just want to make you aware of. So if I write this, that means differentiate x squared. So that would be 2x. And here, this would be 2y, and then something like this would be, for example, 2 theta. So my point I'm making here is that this part here just tells you what the variable is. The variable is x. So as long as it's an x here, all is good. This tells you it's a y, this is a y, this is good. Theta, this is a theta, so this is good as well. The letter is not important, really. So as long as they can match, then everything is just as normal. Yeah, that's something we'll look at in a later section. Just for today, I'm just saying make sure they match. Yeah?
And if they don't match. I know. I'm like,
Yeah, be quiet. Now, what are you asking me about the square? Oh, square is just my example. So like, for example, derivative of sine x would equal cos x. I'm just saying that this symbol here, when you write it like this, means differentiate what's in the brackets afterwards. So it's, you know, it's almost a bit like a verb. You're saying differentiate this. Yeah? No.
alright, so if, I know Nathan already asked you, but that is not going to come. But if it came, and we don't know what the answer is, what do we write? Like, for different letter.
Could write something like this.
Okay.
Yeah. What did you expect of me? You just asked me a question. If I didn't know what to do, what can I do? If I process your question, right?
Yeah.
Yeah, so like, yeah. If you felt the need to write something, you could write that. Yeah. Right. Now, I want to give you one to try. I want to see if you can come up with the answer here. So, I'll give you something like this. 3x plus 4y plus 5 equals 0. And I want you to find dy dx. And I'll give you a little hint. What you should do is rearrange this before finding the derivative. Yeah, rearrange this. I think that's enough. So, before you start, you should change the subject of the formula. Well, think about what you need. Think about the other examples I did. So if you look here, what did I give you? I gave you y, didn't I?
Yeah.
And if you look at these examples, what did I give you?
all
I gave you
y.
y. I gave you y.
So y should be the subject.
Yeah, that's it. That's it. Okay, try this one. It'll only take you a minute. You got this, yeah? So if we rearrange this, we get y equals minus 4y equals minus 3x minus 5. I can divide by 4, and I get y equals minus 3 over 4x minus 5 over 4. So what's the derivative here? Minus 3 over 4. Because this is like a 1 here.
Yeah, and 5 over 4 constant.
And 5 over 4 is constant. What did I say was the definition of derivative?
What?
The derivative is what exactly? The slope of the tangent. What's the slope of this line?
Minus 3 over 4.
So the result should not be a surprise. Yeah? Right, can I remove this?
Yeah.
I need to do another example. So the answer is minus 3 over 4.
Because you wrote it in the form of an equation of y equals
mx plus c. Yeah? Can I go backwards? I need to undo this. Yeah? So I want you to try this one now. I want you to find the x dy. Yeah. Now, if you think about it, nothing has really changed. We are just swapping the subject. Did you get the answer? Yeah. So we get here 3x equals minus 4y minus 5. So x equals minus 4 over 3y minus 5 over 3.
Yeah.
So then dx dy equals minus 4 over 3. Yeah. Well, that's not a surprise, because what did I say dy dx was? Minus 3 over 4. Not perpendicular, reciprocal. The point I'm making with this example is that dx dy is actually simply just 1 over your answer for dy dx. Now, I know that seems like a simple result, but that is actually a very, very useful result. Let me give you an example of how it's so useful. So if I said here to find dx dy in this, y equals x cubed plus x squared plus 1. Can you make x the subject here? No, you can't.
No.
You can't. But can you find dy dx?
Yeah.
Yeah, it's 3x squared plus 2x.
Yeah.
And can we now find dx dy using this result?
Yes.
Yeah, it's going to be just
Overlap it. 1
over
3x squared plus 2x.
minus 3 to the power minus.
this here, yeah?
Yeah.
So I know this seems like maybe even an obvious result, but I've seen this question in the exam, and I think maybe every student forgot to flip the answer at the end. So the question said, what is dx dy? And everybody said, oh great, I know this one, dy dx equals this. But maybe because it was an exam, maybe because people were reading quickly, they didn't realize that, oh, dx dy means I have to flip the answer at the end. So I don't think anybody actually did that. I think everybody, because they were in exam mode, they were reading quickly, they weren't concentrating that the question wanted this and not this. So everybody forgot to flip it at the end. Okay? So I'm just saying it now, be careful, there is a difference, and make sure you read it carefully, dy dx or dx dy. Okay? And the difference is just flipping it upside down. Right, so for homework, you should be able to do ABC. I think in number 2, ABC, and number 3, ABC. But number 1 is very, very simple. I want you to do all of number 1.
Oh.
Yeah, it's very simple. It's like, what's the derivative of, x squared? 2x, What's the derivative of cos x? Minus sin
Minus
x.
sin
So
x.
they're all just one-line answers. ABC in 2 and 3 and all of question 1. Yes?
know when you split up it's dx over dy, you can't make x subject because it's y. But like at second one, dy over dx, y suddenly you make x subject.
Huh? Here to here, it's just a regular derivative, nothing special.
Okay, yeah.
It's just a regular derivative, yeah. Okay. Close this.